G'day team, welcome back to another video. So we're continuing on with our trigonometry. In the last video we looked at solving trig equations without a calculator and with algebra. Now we're going to start applying that skill to using trig functions to model real world scenarios. So we're going to go through an algebraic example today. You can also use a graphics calculator. If you would like to see that video, let me know, and I'll sort out the emulator and we can definitely run through that together. But today we are going to look at it algebraically. So our question we've got here, it's a bit of a long one. So the population of grasshoppers after t weeks, where 0 is less than or equal to t, which is less than or equal to 12, so it's 0 to 12 weeks, is estimated by the function p of t. Once you start using population modeling, we always call our function p, population, with respect to t, which is time. So p of t is equal to 7,500 plus 3,000 times by sine of pi t over 8. So part A, find the initial estimate and the estimate after 5 weeks. Part B, what's the greatest population and when does it occur? C, when is the population 9,000? And D, during what time intervals does the population exceed 10,000 grasshoppers? So let's break this down one by one. So the initial estimate is when t equals 0. So if we're substituting t equals 0 into here, we have sine of 0. We know that itself is 0, so we've got 7,500 plus 3,000 times by 0, which is 0. So we're left with just 7,500 grasshoppers. Part 2 of that question, finding it after 5 weeks. So we're substituting in t equals 5. So we have 7,500 plus 3,000 times by sine of 5 pi on 8. Chucking that into your calculator, I've just rounded it to a nice 3 significant figures. All right, so it's approximately 10,300 grasshoppers. You can use your calculator for this calculation. Part B, the greatest population and when does it occur? So the greatest value for p of t occurs when this sine of pi t on 8 is equal to 1. All right, if it's not equal to 1, you're going to get a fraction and we're going to get less than our greatest value. So we're going to make sine of pi t over 8 equal to 1. Then we're left with 7,500 plus 3,000 times by 1, which is 10,500 grasshoppers. Now we need to figure out when this occurs. So sine theta equals 1 occurs only at theta equals pi on 2. So that is the only angle that will give us sine theta equals 1. Now, that means pi t divided by 8 has to equal pi on 2. And if we rearrange that for t, that is equal to 4 weeks. Now, part C is when the population is 9,000. What week is it? What weeks? So we make p of t equal to 9,000 and we're going to be solving for t. So first of all, take 7,500 from both sides. Then we're going to divide through by 3,000. We've got this nice result of a half equals sine pi t over 8. This is where we now incorporate what we did in the last video into this type of sort of thinking. So remember how we would change our intervals? So our current interval is 0 is less than or equal to t, which is less than or equal to 12. But we've got pi t over 8, not just t. So what we need to do, we need to divide all of it by pi over 8. T divided by, or times by pi on 8 is pi t over 8. 12 times by pi on 8 actually gives us 3 pi on 2. So what this means is pi t on 8 has to equal pi on 6 for the sine of a half and 5 pi on 6 for sine of a half. All right. And what we can do now is rearrange for t. So we multiply both by 8 and divide both by pi. And this comes out to be 8 on 6 and 40 on 6. Therefore, if we're putting it into mixed numbers for weeks, so we're getting a population of 9,000 grasshoppers at 1 1/3 weeks. and 6 2/3 weeks. All right. So part D, what time interval is the population over 10,000? So now we're working with inequalities. Remember, we can treat inequalities just like equal signs to rearrange equations, unless we're multiplying and dividing by -1, but that won't be the case today, so we're in the clear. So 7,500 plus 3,000 times by sine of pi t over 8 is greater than 10,000. Like I said, we're just going to treat it like a normal equation. Take 7,500 from both sides, divide through by 3,000, and we're left with sine of pi t over 8 is greater than 5/6. Now, 5/6 is not one of our nice numbers in our unit circle, so we're going to have to use technology to solve for this. So I went ahead and did that using technology. T is approximately equal to 2.51 and 5.49. Therefore, 2.51 is less than or equal to T, which is less than or equal to 5.49 weeks, and that is the time interval the population is over 10,000. Now, I know that was a big, long question, but this is what it is. They're going to break it down nice and simple for you in these steps. What I can do, if you guys are interested, we can definitely look at showing you how to solve this on your calculator graphically as well. Hopefully this helps, and we'll see you guys in the next video.